Well, I realized after splitting this up that there was not actually enough material here to split up into another lecture. So this is going to be an extremely short mini lecture. This should have all gone together. But that's life. I'm not necessarily very good at this whole video lecturing thing. So here we go. The end of this handout. There's a final question here that isn't really answered in the Ohala paper. And that's why are the cues to the second consonant stronger than those of the first consonant in these situations? So why do we hear this as a ka instead of a pa? Right? And there's two kinds of answers, both of which might be right. One of them is supported by the Fujimura paper that we talked about in the fall. And then there's also some evidence supporting the other theory as well. So these might both be explanations for why. One of the ideas here is that, well, the acoustic quality, just the number of acoustic cues there, their objective acoustic quality before vowels is higher than the cues that are found elsewhere. Why is that? Well, because much of the place information from a consonant is actually contained in the first part of a following vowel. Right? And this goes back to the idea of formant transitions, which we haven't talked about for a while, but you can see these formants moving here. And what they're doing is moving from ka-like targets to a-like targets. And so these movements of these first three formants, even if I cut out the burst of the stop, you'd still be able to hear this as a ka sequence. You don't even need this stop burst to hear the place of articulation here. You can get it from these formants. Right? Um, Consonants that are not before vowels, on the other hand, don't have any following formant transitions. So pa here has preceding formant transitions, but these might just not carry as much information as the following ones do. So that could be part of the answer here, is we just have more acoustic information about the place of articulation of this guy than we do about the place of articulation of this guy. Maybe that's why these ones tend to neutralize and these ones tend to preserve their place of articulation features. Um, Non-prevocalic stops are also much less likely to be audibly released, right? So Steriade talked about this at length in the aperture theory paper. Word final and preconsonantal stops cross-linguistically are very likely to just not have any audible burst at all. We know that bursts like this burst here contain cues to place of articulation. You can almost kind of see the formants even in this little brief burst. That's going to tell us something about place of articulation. So if you don't have a burst, as in this simulated non-released pa here, then you're going to have fewer cues to your place of articulation. So that could be a reason. And the place of articulation cues of consonants preceding stops are particularly likely to be obscured by the following stop constriction, because that's going to completely cut off airflow and therefore sound. So imagine that this pa here is actually a nasal or something. It's going to be ongoing here. There's going to be internal cues to place of articulation. But when you start forming the closure for this ka sound, it's going to completely choke off all the sound in this part of the signal. And so you're just not going to be able to hear the place of articulation cues here as well as you can over here. So these are all reasons why you might think, well, there's just better acoustic information for these prevocalic stops than there is for the non-prevocalic ones. And all of these might be correct, but there's actually also even a second set of reasons why you might get stronger perceptual cues to the second consonant than the first. And that could be that listeners pay more attention to the following transitions after a stop than they do to the preceding ones. This is what Fujimura and colleagues concluded after some experimental manipulations that we're going to skip over for the moment. And yeah, so the idea here is that, well, maybe there's lots of acoustic information to both sets of consonants here, but there's something about the human ear and the human brain that basically make these release cues, this region of time, more salient or easier to pay attention to implicitly than this period of time, the closure period of time. And there's evidence that that's correct as well. And it may be due to inherent properties of the human auditory system, although that's not entirely clear. It might be related to the way that auditory neurons work. That's been put out there. But in any case, there's going to be lots of possible reasons why we might have stronger major place of articulation cues in C2 than in C1. And so there's probably lots of reasons why we would expect both the Ohala hypothesis to be true and why we would expect it to result in asymmetries in phonological typology that we actually find when we go out and look at languages. Now, the last piece here, and this is a really interesting, neat piece of additional argumentation, and this is also due to Donka Stereade, but this is a completely different paper, and it's from her 1997 paper, which is a classic in this area of phonology. So you may have noticed as I've been talking through these handouts, and actually really for the last 8 months or so since 411 started, whenever I talk about neutralizations of place contrast and assimilation of place contrast, I'm always really careful to say major place. Why do I keep doing that? Well, here's why. There's many, many languages in Australia and in the Indian subcontinent that have contrast for minor place amongst different kinds of coronals. And I've briefly mentioned some of these before in both 411 and 611, but they would have slightly different places of articulation with the tongue tip further forward, like a dental stop, a little bit further back, like along the alveolar ridge, a little bit further back than that, so just behind the alveolar ridge, with the tongue tip curled back a bit, a retroflex stop, and there could be various gradations of these. And some languages, I believe, have as many as 4 different places of articulation in the coronal region. So there are Australian languages that do this. This is interesting, right? So first of all, it's interesting because these are super hard to hear for somebody who doesn't speak one of these languages. But they're not hard at all for 8-month-old English infants or for any other infant that's learning an Australian or Dravidian or Indo-Aryan language. But then also these pattern very differently in phonology. These minor place contrasts, they pattern very differently than major place contrasts. And this is what's going to be of the most relevance to what we've been talking about, right? So interestingly, the perceptibility of these consonants is different as well. The contrasts are most distinct during the closure phase of a consonant. And the releases of these different dental versus alveopalatal versus retroflex kinds of consonants, their releases actually tend to be very similar. It's been shown in at least some languages, like Gunyandi, which is an Australian language, that the reason why this is true is because it's really the closures that have different places of articulation, but often in the retroflex or further back ones, the tongue tip slides forward during closure so that by the time it gets released, it's further forward and it looks and sounds more like the dental or alveolar series. And so it's really the closure that's very distinct, and you can hear this. I'll produce, say, a dental versus retroflex contrast in between 2 vowels, and think about what these sound like if you can hear the difference. Ada, arda, ada, arda, ada, arda. It's really that preceding vowel that sounds very different. The release and the following vowel don't sound that different at all. Right? So this is, in some sense, the exact opposite of the case that we just saw above with major place contrasts. Acoustically and perceptually, the strongest cues to this contrast should be in the preceding vowel transitions. Right? So if this were a retroflex followed by a dental, we would expect these cues to be stronger in that case because the retroflex and dental are going to have really similar bursts and following formant transitions. It's the closures that are going to be more distinct here. Right? So it's the exact opposite of major place contrasts. Here's the kicker. If phonology, according to the Ohala type of hypothesis, if phonology cares about perceptibility, and if that's how neutralizing assimilation is taking place, then the situation with these contrasts, with different minor place contrasts for coronals, should be the exact opposite of what we find with major place contrasts. So this whole handout has been about the fact that, hey, place of articulation assimilation is always regressive, except it turns out that's not true. The one place where place of articulation assimilation is almost never regressive is with these specific contrasts in Australian in Dravidian and Indo-Aryan languages, where you have minor place contrasts amongst coronal consonants. And so in most of these languages, if there's any neutralizing pattern, it goes like this. If the contrast is allowed anywhere in these languages, it's allowed after a vowel. So word finally or before another consonant, you will get the contrasts. Frequently neutralizes before vowels when it's not following a vowel. So at the beginning of a word is a very frequent site for minor place neutralization in these languages. Exact opposite of major place neutralization. And when you do get sequences of two coronals in a row in many languages that have these contrasts, they display progressive place assimilation. The second consonant, which is before a vowel, takes on the minor place of the first consonant, which is following a vowel. Right? So this is really neat, and this is really interesting support for the Ohala hypothesis. The question here is something like, hey, do patterns of assimilatory neutralization reflect abstract phonological features or abstract syllable structure, or do they reflect facts about speech perception? And this is really strong evidence that when you change around the facts of speech perception, it changes around the patterns of assimilatory neutralization across languages. This is quite robust in these three families of languages. And so that is really strong evidence that perceptibility is important for determining the distribution of phonological contrasts. This isn't just about which segments follow one another in abstract terms. It's not about syllable structure, word structure. It's not about articulatory ease. There is something about the assimilation processes that we've been studying for the last year that is intricately tied up with the nature of speech perception, and that is interesting. Thank you.